Today we're starting section 7.4, which is on percents and interest. And in particular, when we did section 6.4, in the last chapter, 6.4, we talked about proportions. Do you guys remember that? And we talked about the fact that sometimes things could be solved in other ways, and that's fine. But proportions can be also very useful, and we're going to see that kind of come back up again today. This idea of proportions being used in particular with percents and interest. So to start with, percent. This actually comes from the Latin word meaning per hundred, as in our cent, like the penny, which is worth 1/100th of a dollar. So when we say n%, we mean n out of 100. And probably the area where you use this the most right now as students is your grades. Right? If you ask me what's my grade in the class and I tell you 95, 95 is a percent. It's 95 out of 100% of the points in the class or whatever. Converting between numbers and percent forms of numbers is where we're looking next. I'm going to show you a couple of different ways to do this. So the first method to take a number into a percent is to write the number as a fraction with a denominator of 100. In essence, to multiply by 100 over 100. All right, so 7.9 over 1. And if I multiplied them both by 100, I'd get 790 over 100. And what that does is it puts it in this sort of a view over here. It's n over 100, so that means n%. So 790 over 100 is 790%. Okay, so I know as a grade, we don't usually look at percents that are over 100. That doesn't really, unless there's like extra credit involved maybe, but even that, you're not going to get 790. But there are contexts in which larger percents are completely and totally appropriate. If you talked about shopping, and you were talking about being a retailer who wanted to mark up their products so that they make a profit, they would need more than just 25%. They don't need 125%. They might mark the product up 200 or 300%, because that way then later when certain pieces that are the wrong sizes for whoever came in looking have to go on sale, they're still making money, right? You guys know that, right? When something's on sale, they're not taking a loss, or at least not a deep loss on things. They're still marking it down to a place where they feel comfortable with what they're selling it at. So these ideas of big percentages are okay. Sometimes people get really concerned, like, oh, but that doesn't make any sense. It's a really big percent. It's okay. Not a problem at all. Okay, so big percentages are good. Another way to convert from a percent into, decimal or a number into a percent is to use a proportion. So we can set up our value 7.9 over 1, and we can make it equal to n over 100. And then when we solve proportions, as we discussed back in section 6.4, we would end up taking 790 equal to n. And so that would be our percent. So n is 790% by cross multiplying. Third method, probably the one that you are most familiar with, but I want you to understand there are more ways to explain this. So when the child asks you, but why do I just move it to the right two places? You have other methods to show why. But one way to do this as well is to move the decimal point 2 places to the right. Right, 7.9, I move it 2 to the right, I get 790. Obviously, that's the most efficient of the three methods, agreed? Yeah, definitely. Fastest to go and all that good stuff. But you guys are going to have those kids who are going to ask the questions, why? Why does that work? What's going on? And having other ways to explain it is always helpful. Even if you don't have it at your fingertips, you know that you've seen it before and you can go back and find it, okay? So this is the third method. So what we're going to do is we're going to do a couple of examples of taking numbers and turning them into percentages. Because we're so comfortable and familiar with the third one, I don't want to do that one at the beginning, all right? I'd like to show you those other two methods and how to think about them. So the first one I'm going to do is I'm going to do it with method number 1. So method number 1, remember, takes the number that I'm given, in this case 42.6, and it multiplies, we'll think about it this way as over 1, by 100 over 100. So if I take 42.6 and I multiply by 100, what do I get? I do, 4,260. I have 100 on bottom. And again, the reason I like this form is because it goes back to the definition. The definition said, what is this out of 100? Well, out of 100, it's 4,260. So this is 4,260%, because it's per 100. Percent means per 100. It's almost like you've put units on there, right? The unit is a percent sign, but it's really just an expression that means per 100. 8 over 3. Now, 8 over 3 would not even be useful to do as it is directly by moving over any decimal places, because there aren't any decimal places in the way that this is originally presented to you, right? So if we thought about method number 3, the only way we could use method number 3 is if we first changed it into a decimal, and then we move the decimal point 2 over. Is everybody with me? Okay? Which is fine, and that's a way to do it, but just recognize that if the number started out in fraction form, that might not be your easiest option, because you'd actually have to make 2 conversions to do that. So I'd like to do this one with method 2. Method 2 takes the value I'm given and sets it equal to n over 100 and solves a proportion. So I would end up getting 800 equals 3n. And then what? Yeah, I would divide by 3. And for what we're working with at this point, grab your calculator, I'm fine with that. What is 800 divided by 3? No rounding. What'd you get? And it's percent, right, Summer? Yeah. So either we write it with the 6 repeating on the end, or you might see it written, like if you were looking in the back of the book on this one, just so you know, they might change that 0.6 repeating at the end back into a decimal or into a fraction and write it as 2/3%. I'm not asking you to do that by any stretch of the imagination, but I just want you to know that that's another way it might show up if you're looking for a solution somewhere to that problem, okay? Any questions on those? Okay, so each of these 3 methods took a number, decimal or fraction, and turned it into a percent. Now I want to go back the other direction. I want to take a percent and turn it into its equivalent number or fraction. So there are 2 methods. One of them is to divide the number by 100. Just take whatever it is, divide by 100. The second one, again, the one that's most efficient, is to take the number and move the decimal 2 places to the left. So we're going to do a couple of examples, of course. All right, so the first one is 4 1/2%. This one's not too bad to do it. You might as well write it as a decimal, right? That's what we have. If you think of it from method 1 perspective, I would then be taking 4.5 and dividing by 100. And if you grab your calculator, what will that give you? 0.045. Yes, ma'am. And if you think about it from method 2's perspective, you simply take where the decimal is and you move it 1 place, 2 places to the right, and of course, I don't have the really ability to do that without some extra zeros added in, so there's my decimal. So now my decimal point, 0.045. Either way works. So how about 125% with method 1? Well, you'd write it as 125 over 100. What will that give you?
1.25.
1.25. And if you think about it from method 2's perspective, there is no visible decimal, which means it's actually present after my 5, right? That's where it currently is. And then if I move it 2 decimal places to the left, of course I still end up with 1.25. So moving in and out of decimals and percents, or out of numbers and percentages. Okay, I'd like for you to see 3 different forms a percent application can take on. So application is another word for word problems, right? So when we're dealing with word problems, there are 3 ways that we can see applications come about. One of them is finding a percent of a number. So we're not doing these problems. I'm just sort of describing to you how they would be asked. So if we were finding a percent of a number, the question would evolve into something at least that looks like this. What is 15% of 32? What is a percentage of something else? So like when I went to Kohl's a couple of hours ago and they offered me a discount, they wanted to tell me how much I was going to save. What was 30% of my total purchase price? That's what they told me, okay? This is the same thing you ask yourself when you do your tithe. What is 10% of however much money you made during that week or month or whatever you're doing, right? So we do this kind of an application a lot. The next one, finding a percent one number is of another number. So this kind of a question involves looking at this type of a statement. What percent of 47 is 12? We do this kind of percent a lot too. When you're looking at how something's grown or decreased, right? So like when a school district is wanting to justify adding a new teacher to their grade, they will look at the percentage that the number of students have grown by. Last year there were this many students, this year there's this many students. What percent did it grow by? How many more do we have percentage-wise? Because growing by 5 students is significant if you only started out with 5 students. But if you started out with 152 students and you grew by 5 students, it doesn't make a big difference, right? The percent matters. If you're looking at, should I stay at this job or should I change? And you look at the money you make, you're like, well, I'm only making like 50 cents more per hour. But if you're making 50 cents more per hour and you were starting out making, like $3 an hour, think about the little kids doing the yard work or whatever, and now they're making $3.50, that's a pretty good jump in their price actually. But if you're looking at your wage and you're like, well, I was making like $21 an hour, making $21.50, you might be like, that's not a very good jump in my salary, right? It matters. The percent is actually what gives you more information than the actual numbers. The third way is finding a number when a percent of that number is known. So this is an example of that one. 13 is 45% of what number? And I think of an example when you go to the grocery store and it shows, like Walmart tells you their rollback prices, right? This is what it cost before and this is what it costs now. And if you're looking at it, you're trying to say, well, how much did they discount that by? Well, that's this kind of a question. How much of a discount am I actually getting? When somebody tells me that I'm getting a discount on my car insurance because I have more than one car on the policy or something like that, that discount amount actually will equate to how much money I'm saving, right? There's a relationship there. So what we're going to do for the remainder of this lesson is different problems, or the remainder of today anyway, is different problems of this variety, all right? And identifying which of the 3 types of problems I'm actually doing, because they do set up differently. Similar, but different. So let's take a look at an example. Here's the first question. What is the sale price of a softball if the regular price is $6.80 and there's a 25% discount. So before we actually do the problem, because there's a little bit of a trick in this one, but before we actually do the problem, what I'd like for you to look back at is to try to identify which of the three types over here is this problem. Are we finding a percent of a number? Are we finding the percent one number is of another number? Or are we finding a number when a percent of the number is known? Which of these types is it? What is the sale price of a softball if the regular price is $6.80 and there's a discount? You have a 33 1/3 chance of getting it right just by guessing. Which one is that one? 1? Ding, ding, ding. Good job, Kimberlyn. Yes, it is. It's number 1. We're finding a percent of a number. So this is a problem number 1 type. There's a couple ways to do this problem depending on how you think about it. So the first thing you have to be really careful of is recognizing they told you the regular price and they told you the discount. That's really common on sales, right? They tell you the percentage that you're going to save. But the question they actually asked here is what the sale price will be. So when I get up to that register, how much is it going to tell me that I've actually got to pay them? So there's 2 ways to do the problem. One way is to deal with the 25 as the value. So here's how the problems will always set up. You're always going to set up a proportion, and one side is going to be the percentage side. Okay, so this is, I'll do it on the right-hand side. Sure, that'll work. So the 100% is always on bottom. Everything's always out of 100. And the discount is 25. Okay, everybody good with that? Okay, and then the way the other side of the equation always works is you've got the sale price or the discounted amount or whatever it is on top, and then you've got the original value on bottom. So the original value corresponds to the 100%. This is like when we did proportions before. They still have to line up across the equal sign as well. So where is my 680 going to go? Is it going to go in the numerator or in the denominator? It's going to go in the denominator. So the unknown part is the numerator, and we're going to cross multiply. So I have 100x equals what? What is 680 times 25? What is it? 170 even? Fantastic. Like 170? Or $1.70? $1.70? 170. What do you have? I don't have this one written down. I've got the other method in my 170. Okay. Just making sure I heard it right. And then what would we do as our last step here? Divide by 100. There's my 170 that I was thinking like is in $1.70. Okay, so this is now 1.70 or just 1.7. What did I find? Yeah, and I'm going to phrase it a little bit differently, but it's how much we save, right? It's the discount. It's what Kohl's told me when I said, and they said, oh, look, you saved this amount of money today, right? That's what this number is. And Kimberlyn's exactly right. It's the number I'm going to subtract. So, oh my goodness, didn't mean to do that. Trying to select that, move it over a little bit. So to find the answer to the question, I would actually have to take the original price, which was $6.80, subtract my 170, which would give me what? $5.10, $5.10 with a dollar sign, of course, because we're dealing with money, and that would be my answer. You have to be careful to answer the question you're actually asked. Okay, don't flip your page yet. I want to show you one other way you could do the problem. The nice thing about this method is that you use the 25% you were given, right? The not so nice thing about this method is at the end you have to remember to do the subtraction. And it's really easy to overlook that when you get to the end of the problem. You think, oh, I'm done, and you're actually not because you didn't quite answer the question you were asked. So another way to do the problem is that you could set this up. You have that same 680 over here. And the same 100 on bottom. But you could set this up as a 75% on top. So what in the world did I do? I mean, I don't mean numerically, obviously I subtracted, but what is the 75% representing? Yeah, so if I'm saving 25%, I'm paying 75%. And if I set it up like this, I'll use a different letter just to represent that I'm not finding the same number when I'm done as my first step. I would have 100y equals 510. And then the nice thing again on this one is that I have the answer directly with no subtraction when I'm done. So y equals 510. As long as you're being careful, of course, either way is perfectly fine. Just a little different in how you think about it. Okay, let's take a look at the next one. Any questions on that one before I go on? I'm sorry. Okay. A ski resort reports that 80% of its runs are open. If there are 60 runs open, how many runs are at the ski area? So the first question is, what type of problem is this? Yes, which is 3, right, Summer? Good job. This is a type 3 problem. So let's see what they give us again. We have a ski area. They report 80% of the runs are open. There are 60 runs open. How many runs are at the ski area? So as we're setting this up, again, one side is going to equal something over 100, and the other side is going to represent my ski runs. So the percent that they give me in this problem is an 80, so that would be my 80 over 100. The question is, where does 60 go? It's up top. The 60 is representing the 80% that are open, so it's along the same location as the 80, right? The 60 and the 80 go together. And what I'm trying to find, in this case, is the denominator. How many runs does the ski slope actually even have? So we can cross multiply. I have 6,000 equals 80x. And if I divide by 80, what do we get? 75. And just like on the last problem, when I put a dollar sign, I need to put units on this one as well. 75 what? Runs or ski runs or lanes or any of that's fine, I don't care. But yeah, I think they call it runs in our actual problem. So we'll do runs, 75 runs. Okay, everybody good with that? Okay. Example 5. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? So, which type of problem is this? 1, 2, or 3? It's 2. It's finding the percent of one number when another number of what one number is of another number. This is type number 2. Okay, so this is another really good example of 2 ways to do the problem. So I'm going to let you tell me how you perceive the problem. What would I set it up to be? And then after we do the problem that way, I'm going to show you the alternate setup. Okay? So what would you do if you were setting up this proportion? How would you set it up?
$159,000 over $195,000 and X over 100.
Oops, 100, sorry. Okay. What do you guys think? We will. These are actually upside down. which is a really common tendency. We have this feeling most of the time that we need to have the larger number on the bottom, and this one it's not. So, Summer, what made you think that we need to switch those? Or why would you think that we would want them that way? Okay. There you go. The original is what goes on bottom, and the original on this case was the 159. Okay, so they've got to line up. The original price is the 100% price. The new price has increased. Okay, everybody good with that so far? Okay, so this is definitely one of the ways to set up the problem. That was teamwork. Good job, guys. All right, so we're going to cross multiply. 195,000 times 100 is actually 10 million, 19 million rather. 500,000 equals 159,000 x. So then if I divide by, or you divide by 159,000, what do you get? Say it again.
1,226.4142.
Okay.
I got 122.64.
Oh, I put it.
Okay, that's what I was thinking. Like, unless I've got something written down wrong, I think you've got the decimal in the wrong place. Okay, and it said to the nearest percent. So if we round to the nearest percent, Matthew, what do you have?
123.
123. Okay, good. All right. Sorry, just checking to make sure I didn't have an error on my stuff too. 123. So are you good, Demi?
Yes.
Okay, cool. 123%. Now, I always want to make sure you answer the question that was asked. The question asked, what is the percent of increase in the value of the house? Is the answer 123%? What is it, Kira? It's 23%. The answer is 23%. So let's talk about why, and then I'll show you another way to do the problem that makes it a little bit easier to see the answer at the end. The 100% price is where that 100% of the 123 is. Are you with me? Like if I did this problem and I put 159,000 over 159,000, I'd get 100%. It's the exact same value it was. It didn't change. So the 23% is the increase in the value over the 100% it currently started at. Make sense? Now, why did that happen? Well, that actually happened because in our numerator, we put the new value of our property. We didn't put what the property value's change was. So we could have avoided this sort of question at the end a little bit, kind of like that other problem with my 75% and 25%, if we set it up with the increase in price on top instead of the whole new price on top. So if I had my 159,000 on bottom, and I had, what was it, x over, well, I'll do it as y for a moment, x over 100 over here. If on the top right here, we did the 195,000 minus 159,000, which is 36,000. And we put 36,000 on top because 36,000 is actually the increase in value, right? And if we use this number instead to do our multiplication, we'll get the 23% immediately. So this would be 3,600,000 equals 159,000. And then double check. Take 3, 6, and then the 5 zeros and divide by 159,000. What do you get? Did you get 23? 22.6, and then if we round to nearest percent, it'd be 23, right? Cool. So 23%. Okay, so again, either way works, doesn't matter to me in the slightest, but just recognize that you have to be careful some point along the way that you're answering the question that was asked. The question that was asked here was about the increase in the value. So we either have to address the question at the end to get the 23 out of the 123, or at the beginning to change the 195,000 to 36,000, okay? All right, we're gonna take a look a little bit at some mental math stuff next. Okay. Mental math. The whole idea of mental math is that we do it in our heads, right? The problem, and many of you have heard me say this before, is that I can't see what's going on inside your head. So although it's mental math, and yes, it should be able to be something you can do in your head, you have to write for me down what your head's doing so that I can see it. Make sense? Okay. That said, the usual problem that I have is people doing work that's not mental math. So they see this and they say, oh, look, 15% of 42, and they take 42 and they multiply by 1.5. And I don't know about you, but I do not multiply 42 by 1.5 in my head. I just don't, or 0.15, I mean 0.15. I don't do that. That is not how I would ever do this problem if I were without my calculator. That's not how we think. So what would we do? So I'm going to show you a few cool tricks with mental math and percentages, because there are some really fun ones. All right, so you guys would be able to answer this question very easily if I asked you for 10%, correct? Yeah. What is 10% of 42? 4.2, right? And you do that because we move a decimal, correct? But if I know what 10% is, can I find what 5% is? Yeah, and how'd you do it, Summer? Yeah, you divided it in half, right? This is half of 4.2. And then if I know the 10% and I know the 5%, what could I do to get 15%? You can add the two together, and you'd have 6.3. That's easier than multiplying by 15, which is equivalent to what I would have done, right? Two-digit multiplication in your head. I mean, like, that's great, and we always see those little kids on TV who have the skills to be able to do that really fast in their head. Have you guys seen that before? Like, they're on talk shows. They show up on, you know, like the David Letterman show or something. Like, that's not even a thing anymore, is it? Does he have a show still? I don't even know. But they show up on those talk shows at night, and you're like, wow, that kid's amazing. Okay, but that's not probably the kids, or at least not all 25 of them that are in your classroom, right? They're not. They need other strategies to be able to do the problem if they're going to do it in their head, and this is a really good one. Again, it works really nicely because it's 15%, right? 10 and 5, and that's great, but I think that you could probably figure out how to do now the 20%, right? What would you do to do 20%? You do 10 and 10, so what's 10% of 280? 28. And you could either do the 10% again if you wish, or you could simply double it. What is the 28 and the 28? 56, yep. And it had symbols. It was a dollar sign on both of them, wasn't it? Here, go back and put it there too. So $6.30, $56. Okay, so far so good? Okay, let's try another one. But I bet you're going to know what to do. 10% divided by 2. So what is 10% of 32? 3.2. And what would be 5% then? Yeah, it'd be 1.6. It's not quite as simple as the last one just because of the number that it happened to be. But we can still divide 3.2 by 2. We get 1.6, and it's still dealing with dollars, so it's $1.60. Okay, so based on the work that we've just done, we could do D the same way. We could find 10% and double it. We can find 5%, and then we can add all that together. We can do that, and that's okay. There's nothing wrong with that. But there is a quicker way to do this one that's very specific to the fact that this is 25%. Any thoughts about what makes 25% so special? It's 1/4. 25% is the same thing as 1/4. And the reason that that's so helpful is because I'm dealing with 84. 84 divides by 4 very nicely. If this number said 80, it wouldn't be so nice. But 84 is very nice. Not 80, but 81 is what I meant to say. Yeah, 81, it would not be so nice. Okay, so what is 1/4 of 84? What is it? 21. Okay, so again, like, could you find 10%? Yes, you could. 840 and 840, and half of that would be 420, and you could add 840, 840, and 420, and you could do that, but it starts to get a little bit cumbersome in your head because you're going to be carrying a few things, right? It does. It's a little messier. Dividing by 4, simply because of the numbers we're working with, works out on this one really nicely. All right, I have one more example for today, and then we'll pause. Example 7. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price?
150% is bigger than 100, so if you took that away, you'd be taking away more than 100%.
And what would you end up with if you tried to do that, Brooke?
A negative number, so in theory, they would be giving you money?
Yes, good job. Okay, so that's the reason we can't have the decrease, right? Okay, so what Brooke said is 150% is bigger than 100% of the price. So if I were to take away 150% of the price, they would actually have to be giving me money to take the item. And that doesn't make sense, right? Nobody pays me to take the t-shirt away from the department store. They might give it away at some point if it just flat out will not go away. But they would not pay me to take it. What would it mean to have an increase of 150%? Let's say an easy number. Let's say that the shirt cost $10 for Walmart to buy it. What would it look like to have an increase of 150% in price? Yes, they would. How did you get 25?
So they're doubling it because they're doing 100, and then they're adding half of what the original cost is.
Fantastic. So I'm going to write down a little bit what you just said. Okay, so let's do the increase in price one, and then I'll write down the decrease in price. We've already talked about it, but so for example, a $10 shirt increased by 150% would cost $25. Okay, so why is it 25? Well, an increase of 100% would simply mean doubling the price. We go from 10 to 20. And I have to do that again half as much because 50% is half of 100, so that's $5 more. So this would cost $25. Nothing wrong with that, right? Totally possible, in fact, quite likely. But a decrease would mean, it would really mean subtracting $15, right? Subtracting $15 from $10, i.e. paying the customer $5 to take away the shirt. Does that make sense? So I can increase $15, no problem, cannot decrease $15 in this particular example. All right, so what we have covered at this point in this lesson is all the stuff related specifically to percent. The other part of the lesson title here said and interest, and we'll do the part that says and interest on Friday.